In problem number 27, Karen opens a bank account for her son on his first birthday with a $100 deposit. After that, $50 was deposited into the account on each birthday. No withdrawals and no other deposits were made until his 11th birthday. The bank pays 8% interest per year, compounded annually. And which of the following recursive sequences models the amount of money in the account after n years, when n is greater than or equal to 1 but less than or equal to 10? Now with this problem, there's a couple of things that you need to take into consideration. She starts out on his first birthday, and she's going to continue putting money in for the next until his 11th birthday. So when it says n goes from 1 to 10, that 1 to 10 really means from the first birthday to the 11th birthday. So the birthdays really go from 1 to 11, but she just put some money in on the first birthday. It doesn't accumulate any interest until the second birthday. And so n going from 1 to 10 really starts on the day of the second birthday and goes to the day of the 11th birthday. Now, on the first birthday, she deposits $100. And 1 year later, how much is she going to get? Or how much will there be in the account? And I'm just going to put a 0 in there for n, the value of n on the first birthday. By the time of the second birthday, when n is equal to 1, the money's been in there for a whole year, so she's going to get 8% on that. And how do we add 8% to a sum, to a quantity? We do that by multiplying by 1.08. And you can see in each of the answers below, you're multiplying times some quantity a, that's the amount, a of n minus 1. A of n minus 1 means, well, what is the amount of money that was in the bank at the start of the previous year? So at the end of the first year, on the second birthday, when n is equal to 1, we're going to multiply 1.08 times a of n minus 1. How much money was in the bank at the previous year, or at the beginning of that year? And then we're going to add $50 to it. And that becomes the amount of money that's in the bank at a of 1, or in this case a of 1. So we had to multiply 1.08 times the amount of money that was in there at 1 minus 1, or a sub 0, when n is equal to 0. And so that would be, when n is equal to 0, the amount of money in the bank was 100. We're going to multiply that 1.08 because that money stayed in the bank for the whole year. And then at the end of multiplying, we're going to add $50 new to that. And that's going to be the amount of money in there at the end of the first year. And so just from this, we can see where the answer will be. Well, the answer will be answer B. Now let's look at why it couldn't be answer A. What's the difference between A and B? Well, everything is the same, except instead of multiplying a of n minus 1 times 1.08, we just multiplied that by 0.08. And all that's going to give you is the interest on the money that was in the account at the beginning of the year. And then we're going to add 50 to that. Well, that's going to be the amount of money that's increased in the account, but that doesn't give you the amount of money that was already there to start with. So that's not going to work. Let's take a look at answer C. Well, what's different between C and B? Well, what's different between C and B is that in C, the $50, the new $50 that's added at the end of year 1, was also multiplied by the 0.08. And so that means that we're giving them interest on that $50 that they just put in at the end of the year, and that's not correct. And answer D says that we multiply 1.08, which is good, times the amount of money at the beginning of the year, at the beginning of that year, plus 100. Well, no, we're not going to multiply 1.08 times the amount of money at the beginning of the year, which was 100. We're just going to multiply it by the amount of money at the beginning of the year, not the $100. Without that, D would have been correct. C, we shouldn't be multiplying by the $50, or 1.0. First of all, it's 0.08, and the 50 should be outside. And in A, we multiplied by 0.08 also.